unify your telemetry stack with OpenTelemetry. Going through why you might want to start to think about, standardizing on OpenTelemetry, what that would look like across each different type of telemetry, and some strategies as you kind of go through that journey. Before we get started, we've got all of these webinars here on our website at observIQ.com. If you head over there, there's a tab called Resources right up in the nav bar, and you'll find a link to our OTel hub. That's where we put all of our OpenTelemetry content. Really, it's quickly becoming a library of content for to help you, kind of on your journey as you adopt OTel. So all the webinars are there. We'll of course upload this one as well. As we go through the webinar today, if you have any questions, just post them in the chat. We'll pause occasionally throughout and answer some. And of course, we'll have some time at the end as well. So with that, I'll hand it over to Mike and we'll get started.
Great. Thanks, Ryan. And thanks everyone for joining. Like you said, if you have any questions along the way, happy to pause and answer them while we go through it, or just hold them for the end. But like Ryan mentioned, we're going to talk a little bit about OpenTelemetry, but specifically around some of the benefits of unifying telemetry together, and then some of the challenges that you have when you're not necessarily using OpenTelemetry everywhere. So having the ability to integrate in existing telemetry pipelines or existing agents, existing components. We'll give a few examples of that. I've talked a lot about OpenTelemetry in this, so I'll keep this piece brief, but just as a reminder, and when we think about why it's important or useful to adopt OpenTelemetry, there are a few key pieces, one being standardization. So if you have a large environment and you have multiple telemetry signals that you're collecting, you have multiple backends, it gets very complex very quickly. And there are a number of reasons why you may want to standardize on one, and why OpenTelemetry is, we think, the best standard to choose. But there's also vendor neutrality. You use OpenTelemetry with nearly any vendor, and it's becoming more and more the standard, even the native implementation for vendors. And that's because of this really massive industry adoption that's happened very quickly with OpenTelemetry. We're mostly focused on standardization today. And some of the benefits of that are interoperability. So if you standardize on OpenTelemetry, you can use this, you can use the OTLP for all of your processing. You can use the same agents, you can use the same SDKs, no matter what you're doing, no matter the type of telemetry. Performance can be a big component as well. Performance can mean a lot of things. And it can be performance of the agent itself, the ability to offload workloads onto gateways, performance that comes from reducing the number of agents and the ways that you're collecting that telemetry. So there are a number of different aspects to that, but all of it adds up to performance throughout an observability pipeline. Control comes to your ability with standardization on OpenTelemetry and with a OpenTelemetry based observability pipeline to manage, route, control the data, and do that easily. And then of course, centralizing it all into a single solution. A few of the key concepts in OpenTelemetry when it comes to standardization. One, and this is really at the core of OpenTelemetry, are their semantic conventions. And that's implemented within the data format, specifically OTLP. And when we talk about this, when we talk about telemetry, ingesting it and sending it into an OpenTelemetry pipeline, all of that telemetry is going to be in OTLP format. And having it in that standard allows you to do a lot of really powerful things, but that is the core standardization, one of the core standardizations of OpenTelemetry. Next is configuration. So when you switch to a standard, when you switch to OpenTelemetry, You no longer have to manage all of the different proprietary configurations, whether that is the way that you're ingesting, the way that you're configuring agents or SDKs, the way that you're processing that data and configuring the processing of that, or the way that you manage it on the back end. So in the destination, in most cases, it's going to simplify that significantly as well. And today we're specifically looking at the impact of that single set of tools. So whether it's the SDKs, APIs, libraries, and the instrumentation component for tracing, or the OpenTelemetry collector used primarily for metrics, logs, and then also processing. Just a very quick refresher on the collector before we jump in, but there are three core components to a collector. There are the receivers that allow you to ingest or scrape metrics, logs, traces, processors that let you transform, really, and that can include everything from some simple filtering to redaction, batching, and then the exporters that allow you to transmit that data to a destination. And so when it all comes together into what I call fully standardized observability pipeline, or maybe the ideal observability pipeline, this is what it might look like. It is a large estate of OpenTelemetry collectors. You have your gateway groups. So these scale out and they allow you to expand and handle massive amounts of telemetry. And then it handles the routing to your various backends. Within those and alongside those agents are also OpenTelemetry instrumented applications using SDKs for traces. And there could be a lot of other components, but ultimately OpenTelemetry provides the tool set that you need for really everything that you would need in an observability pipeline. And so we think of this as ideal and usually a target that we move towards. But we also know that within most environments, the reality is that it's far more complex. And so there's an ideal state where everything is OpenTelemetry. We have this architecture that's well understood. It's completely standardized. But when we talk about standardizing, there is this component of, we know we have a very diverse environment. We may have legacy systems, legacy agents, or instrumentation, or it may just be components that we don't want to change, or for certain unique use cases, it's not going to be an OpenTelemetry solution. And so the question is, what do you do when you have a diverse environment, or you have other types of instrumentation, other types of telemetry that exist, and you don't want to go through the effort, or can't, to completely replace them? And so we still can standardize, and that's what we want to talk about today, is some of the strategies for those and examples for some of these specific use cases. And we'll look at three specific examples, taking one for metrics, logs, and traces. And in this case, we're using popular open source solutions, but you can think of this as, the open source solution here that we're showing could be a proprietary solution, and there would be a similar option for solving that challenge of ingesting telemetry into the pipeline, into the OTel pipeline. So we'll look at Prometheus. I found most of our customers, most people we talk to, have Prometheus somewhere, or are using metrics from a Prom exporter. A very popular solution for metrics. We really see it deployed almost everywhere. So we'll look at that and how to ingest Prom metrics into a OTel pipeline. Also look at FluentD, again, another very popular solution that we see in many cases. And a lot of times people don't want to remove some FluentD instrumented applications unless they absolutely have to. But it's really easy to actually to move that and to pull that telemetry pipeline into the OpenTelemetry pipeline. And then finally, we'll look at traces. And in this case, we'll look at Zipkin. but again, could be proprietary trace libraries as well, and how to pull that into your OpenTelemetry pipeline. With all of these, we're really trying to, or we assume that there is an existing OpenTelemetry observability pipeline, something like this. So you have OpenTelemetry agents, you probably have some gateways, and you're sending it to some destinations. So if we look at the first one, we'll jump right into a Prometheus example. And if you have some familiarity with Prometheus, this will be familiar to you. This is pretty common and simple configuration for Prometheus, monitoring a Postgres server, for example. In this case, we have a Postgres instance running. It exposes a Prometheus endpoint that allows you to scrape metrics from that instance. So by default or easily enabled, you have a Prometheus endpoint that will provide key metrics for this application. Now, we chose Postgres as an example, but it really could be any application that has Prometheus instrumentation available. And so for a scenario like this, we would typically see a Prometheus server that is here and is scraping those Prometheus endpoints and maybe reaching out to many instances or many different application types. And then a metric backend could be something like Grafana or others that are using this Prometheus server as a backing data set. So very common. And then the question is, if I have this in my environment, how do I bring this into an OpenTelemetry pipeline? And there are a couple of, in this case, there are a couple of easy ways to do that. And this is the first. So again, assume that this is your OpenTelemetry pipeline that already exists. And we want to shift from a separate Prometheus only backend to pulling this into a standard pipeline. And the easiest way, and the way that is supported for all Prometheus endpoints, is to just include a Prometheus receiver on an OpenTelemetry collector. This receiver can scrape Prometheus endpoints and will then convert that to OTLP, and then it's available within your pipeline. And you can still send this to whatever the destination is. You can still use Prometheus server as backing for your data. But you can also do all the processing that you're used to within OpenTelemetry, and you can then route the data to multiple destinations. So you're no longer tied to a single pipeline. You've now brought it into your OpenTelemetry pipeline. And just in a simple example of configuring this. So to do what we are showing here, we're adding Prometheus receiver that's targeting a specific endpoint. That's just adding in this receiver with the basic configuration. So things like the job name, the metrics path, how frequently we'll be scraping those metrics, and the target for that receiver. I'll show another example of that in a second, but that was an example of Postgres, in this case using Prometheus, but there's a lot of flexibility with OpenTelemetry. So we'll mention one more here, which is you could also, because OpenTelemetry provides a receiver that monitors Postgres natively, you could also include a collector and then implement that Postgres receiver for a full set of data and also collecting log data alongside the metric data. So two options for implementation. The most generic and the one that will work in pretty much any instance where you have a Prometheus endpoint is to use a Prometheus receiver. And then depending on the use case, you can also simply pull the data using a dedicated OpenTelemetry receiver. And something like that, in this specific case, a Postgres receiver similarly has a collection interval and endpoint, but then it also has some additional details. So it will recommend or require a username, password, and some other details to get the metrics from inside of the Postgres server. I can show what this looks like within BindPlane as well, which can help understand some of the options. So what we're looking at here is a OpenTelemetry collector that has a Prometheus source configured. And this is, just like we had shown here, Prometheus receiver connecting to that Prometheus endpoint. You can see, since this is local, we're just pointing it to a local host, the 9187 port, and give it a job name. And then it's connected and pulling all of those Prometheus metrics. And in this case, we're sending it to honeycomb destination. And if we look at the configuration file for it, this is the OpenTelemetry configuration that's created. It'll look very similar to what I showed you. So we have a Prometheus endpoint, a receiver connected and configured, and then a honeycomb OTLP destination. But the power of this is that once it's within the OpenTelemetry and an OTLP pipeline, we have access to all of the OTLP processors. So this is showing the input that we're seeing from that Postgres Prometheus endpoint. So we can see the metrics that we're receiving. And you have access to the full array of filtering, reducing, parsing, and transforming those metrics, just like you would with a purely native OTLP data flow. Now, one more example, because I showed how we might do that with Prometheus receiver or Prometheus scraper, but I also mentioned that we can do that with a Postgres receiver as well. So we'll choose a Postgres source here. And I have one that's configured with the credentials already. And so if I remove the Prometheus endpoint, I've just changed that configuration to include Postgres. You can take a look at the requirements here. So we have the endpoint transport the username. We can also enable logs if we wanted to. Now we're adding in a log component of that. And I'll save this. And if I roll this out, that would push that configuration down. I'm going to move on so we have time for some of the others, but it gives you an idea of what that would look like if you did it in both, using both options. And in this case, if I go back and look at the configuration that we've created, I can see that we have a couple of new components, a receiver for the logs, where it's collecting against these known log locations from Postgres, and a receiver for the metric receiver within OpenTelemetry. But everything else is going to be very similar. So that's what it would look like in one example of taking it from taking metrics from a Postgres endpoint, and a couple of the ways that you could bring that into your OpenTelemetry pipeline. Let's look at what that would look like for logs. Here's a really common setup for FluentBit. You probably have an environment or something similar to this. This could also be, FluentD. It could be a completely separate or proprietary log agent. And the vast majority of these are going to be, of those would be very similar in the approach to migrating them over to OpenTelemetry. So we have an application generating logs. We have a FluentBit agent that's configured to collect those logs, may do some processing. And in this case, it's sending it to an Elastic instance. So now the question again is, this is currently configured with a separate pipeline. It's FluentBit. There may be dozens or thousands of these hosts with FluentBit agents with their own pipeline, but we want to merge them into an OpenTelemetry observability pipeline. And this is what that would look like. So here's our observability pipeline built on OpenTelemetry. We don't want to remove that FluentBit agent in this case. We just want to redirect it. And we can do that within OTel very easily. And there's been a lot of collaboration between the FluentBit folks and the OpenTelemetry folks to make these interoperable. But there is a receiver within OpenTelemetry that supports Fluent forward protocol. So it's as simple as adding in that receiver and then redirecting the output from FluentBit to the OpenTelemetry collector. And as I mentioned, it's very simple. It's simply initializing the Fluent forward receiver and then adding an endpoint to listen on. In this case, 24224. And then an optional, or optionally, you can also move the processing. So I mentioned this because, like I said before, sometimes you have a lot of processing within the FluentBit configuration. It's perfectly fine to leave all of that there. However, if you're starting to migrate, you can also migrate some of that processing to the OpenTelemetry collector and reduce some of the potential load on this system and move it to a collector gateway. And let's take a look at this. So like I mentioned, this is another, in this case, a fleet of collectors. There are 3 collectors here. And each of them is running this configuration. It has a Fluent forward receiver that's configured, has a number of processors, and then it's sending that to a Google Cloud instance. So we can see the receiver is just like what you saw. There's some processors that we'll talk about in a second. That includes quite a bit of processing of the data, and then an exporter to Google Cloud. And just like before, if we go in, we can see the logs that are present. These are all being sent from that FluentBit collector and then through and into the OpenTelemetry collector. And one thing that we wanted to look at, in this case, what we did was we pulled out some of the processing that was happening originally inside of the FluentBit agent. So it's doing things like parsing JSON and severity fields and timestamps and move them into the OpenTelemetry collector. So all of that is possible and can be done here. And you can see that the raw log body is just a JSON structure. We parse out the JSON and create these unique fields. We parse the severity fields as well. So you can see this goes from a raw log to including things like info and error. And then we parse the timestamp into an appropriate format. And again, now that we're in this structure, we can use all of the tools to manage OTLP. So we do things like accept our processor recommendation for deleting empty values. We'll accept that. And we could also do things like filter by severity. We know the severity. And we will filter anything that is beneath the warning level. So we've processed it. We have the ability now to work on that data with processors that exist and reduce it now that it's within an OpenTelemetry pipeline. And we'll roll that out, and then in a couple minutes, we'll have a sense of what that data reduction looks like with those additional filters applied. So that would be a simple example again of using or shifting from FluentBit into an OpenTelemetry pipeline and what's required to get there. And then the last is wanted to give a quick example on traces. So for in this case, we're going to talk a little bit about Zipkin. in a typical scenario for Zipkin, which would be your own custom application instrumented with some Zipkin client libraries for tracing, and then a Zipkin server to manage that. And Zipkin server currently doesn't natively ingest OTLP, where something like Jaeger does, and has shifted to OTLP and OpenTelemetry entirely. But we can add in an OpenTelemetry gateway or collector, and also a Zipkin receiver. And with that Zipkin receiver, we can pull the data from the Zipkin client. So just like the other examples, we can do the same thing with traces. And if you're using proprietary library, there is likely a very similar solution, a receiver that will allow you to ingest that other format, or, and we're seeing this more and more proprietary trace libraries are supporting OTLP natively. So for a lot of vendors, it's as easy as changing the output format, or potentially even just changing the output destination for your trace library. And then you can shift it from using the proprietary agents or sending it directly to a destination over to using an OpenTelemetry collector and getting it within an OpenTelemetry pipeline. Again, really simple. With this, just adding in a Zipkin receiver, adding in the endpoint, and then everything else is handled. It's converted into OTLP. It's in the standardized OTLP format, and you're good to go. So again, the goal of all of this is to go from what is a OpenTelemetry only or a mixed environment with OpenTelemetry and proprietary or other open source solutions, and create a telemetry pipeline that is as standardized as possible, knowing that there are going to be some of these edge cases where it makes more sense to keep them as is and just pull them into the pipeline so that they're following those. They're standardized as soon as possible, and that's really what we think of as a best practice. Is the sooner you can get this telemetry into a pipeline, the better. Whether that is immediate instrumenting with OpenTelemetry so that you're gathering that data, raw data into OpenTelemetry, or if it's collecting it with a other third-party agent or proprietary agent, and then sending it to a collector so it's converted into OTLP. And just to call out where this comes into play, if you've seen some of the other webinars, you may have seen migrating to this piece on migrating to OpenTelemetry. And if not, or if it's interesting, there's a full webinar just dedicated to this. But like we said before, most companies have existing deployments, and you may not migrate all of those at once. So our recommendation is the first phase is deploying OpenTelemetry in greenfield deployments, or if you have new applications being deployed, or a group or team that really wants to work with OpenTelemetry, that's a great spot to start. And that allows you to build this out, build up the expertise with OpenTelemetry to go to phase 2. And this is what we've been talking about today. It's really this phase 2 component, which is redirecting a lot of the existing instrumentation into an OpenTelemetry collector. So it's kind of a shortcut to standardization. I think a lot of people, at least initially, think we need to re-instrument everything to have an OpenTelemetry pipeline, but that's really not true. And in most cases, it's as simple as reconfiguring, and then you can have either replace the existing pipeline that you have, or you can start to shift those workloads over to OpenTelemetry, or if needed, you can run them in parallel. And then again, our phase 3, usually this is as far as we recommend going, which is you may start to re-instrument existing applications or existing hosts, but there are probably some things that are not worth it. Some legacy implementations that you just want to leave in place, and it's not worth the effort or the risk to go in and replace them with OpenTelemetry versus simply leaving those applications running and reconfiguring. That was it for today. I'd love to take some questions if anyone had any. observIQ, I've shown BindPlane a couple of times. We do a lot of work with OpenTelemetry, and it's really at the core of our product BindPlane. And BindPlane is just designed to make it much, much easier to use. Please see some of that within this demonstration. It allows you to manage OpenTelemetry at scale and also manage those pipelines and configurations while you're doing that. There's a big focus on processing, reducing the amount of data you're sending, and reducing the total cost on those destinations. Well, pause for a second and see if we have any questions before we wrap things up for today.
Yeah, one question, Mike. With Prometheus metrics specifically, are there any gaps in the conversion from, Prometheus to OpenTelemetry format?
I can't think of any specific gaps in that conversion. I think where you would run into the place I would think you could run into some issues is with higher sampling and just making sure that those are aligned. So if there's something that you're finding that doesn't seem right when you re-instrument or you're pulling data from a Prometheus endpoint, getting it to destination, and you're noticing that something isn't lining up, I'd be looking at how you're sampling and how you're collecting the data. And then, of course, because you can process along the way, that's something to consider. So, really have to look at what the end state and end goal is. And if there are cases where you find, hey, I really need this to match exactly what I had before, and by match I mean not that the metric values are the same. There shouldn't be any change or any concern about that. But if it's something like the frequency of metrics, the structure and format needs to be and really is reliant on a Prometheus server, you can run these in parallel as well. And that's something that we've recommended before, which is you can still use a Prometheus server and scrape those Prometheus endpoints as long as you need to, while also pulling those metrics into an OpenTelemetry pipeline to use for other applications.
Awesome. A couple more questions that came in. One is essentially the same question, but talking about the Splunk Universal Forwarder and if any data loss can be expected.
With the Universal Forwarder, and Ryan, you may be able to answer this one. The only thing that I'm aware of, some metadata that needs to be considered when you're sending from a Universal Forwarder, but typically that can be replaced with some additional processors in OpenTelemetry.
Yeah, that's right. The OpenTelemetry collector can accept cooked data from the Universal Forwarder. And there is a few pieces of metadata. Usually it's not critical. Sometimes it's important that it gets included when the data is cooked. And we've got some documentation on that on our website. Does observIQ provide any extra components, any receivers, processors, exporters outside of contrib?
Yeah, we do. Although it's that list is getting smaller and smaller, and I'll tell you why. Our approach has been, there are some receivers, there are some processors that we develop, and either something that we are think is really critical and missing from OpenTelemetry, or maybe a customer has a strong need for a specific receiver or processor, and we'll develop that and include it in our distribution of OpenTelemetry. But our intent is always to upstream that. And so as a company, I think we've developed over 40 receivers and probably close to that many processors. The vast majority of those go upstream, and the intent is for them to go upstream to the contrib repo whenever possible. Some of them, especially with the processors and some that I showed you, those are still unique to the observIQ distro, but they are open source and available if anyone wants to pull them into their own distribution of OpenTelemetry.
Great. Looks like two more. How do you detect duplicate metrics when receiving both prom metrics and native OTel metrics from the agents?
I think it depends on, I would say first, or the most important thing is to try to avoid that. If that's, or if the question is getting at situations in one that I may have shown, and I can jump back into this for a second. Well, I showed the ability to gather directly from Postgres, and then also to use Prometheus endpoint. I will show you something you don't want to do, and this is not a configuration that you want, because this is gathering the same metric multiple times. Now, if you're trying to detect those, I would say it's probably an architecture issue that you're running into, where maybe you're gathering multiple times, or it's being sent multiple times. So the first thing I do is try and solve that. But if you are looking for something and trying to, you can't solve that, or you can't solve the architectural issue that's creating duplicates, I would be looking at some processing capabilities. And so if you can at least get those data streams standardized in OpenTelemetry or OTLP, and then do some processing of the streams to look for and merge and deduplicate. This isn't quite what you're asking, but to give you just an example of this with logs, there is a deduplication processor that's available. And what this will do is it looks for identical or very similar logs. And you can do the same thing with metrics, where you're filtering those out or combining pieces with similar or identical ID information.
All right. Do you have any new methods of config maps for providing passwords on a host-based collector?
Sure. Fully follow that question. Some config maps. No, but I can say that, well, I would say that when it comes to, say, passwords or credentials, with OpenTelemetry, there are a couple of different methods for managing those. We have some integrations that are in the works for some of those secret managers like Vault and others to allow for some more flexibility. But we can follow up and send some details on what's available to folks. I think we have contact info that we can send them out to you for the options that are available today.
Perfect. Are all 990 built receivers exporters available in BindPlane to add via the UI?
They're not today, not out of the box, and but I would say many of them are, and then many more that are not necessarily available within contrib. So I would say maybe it's 75% of the receivers that are in a place where we would consider them, that they are stable and are useful, and we are pretty inclusive for that. I'll also say that one of the things that'll be coming out soon is our ability to manage any OpenTelemetry distribution with some specific requirements being met. So be taking OpenTelemetry and allowing you to bring in different components. It's really easy for us to add receivers, but some customers have requirements for a much, much smaller agent. And so it allows customers to really minimize that to just the smallest required footprint for any collector based on their specific needs. So that was a long answer, but the short answer is not all 90 are there today. Many of them are. Would love to hear if there's something that is missing that you think would be useful in your environment. And then in the near future, we're going to allow customers to have more control over that and be able to add their own.
All right, we got one more that came in. Is it possible to limit the consumption of CPU?
Yeah, this is functionality available within the collector. And there are a number of different ways that you can do this. And I think there's some content available on this in another webinar, but it depends on where that's coming from. You can always limit it within the collector or set maximums, whether it's on CPU or memory. Typically, what we would recommend is not necessarily to set those hard limits, but to take any processing that is a problem. So if you have a collector on a mission, and maybe it's a critical workload, and it's important that you maintain minimal footprint, whether it's CPU, RAM, or disk. We recommend that you just gather the raw data and send it as quickly as possible, that you don't do any processing on that edge node, but that you move all the processing to your gateway. So when it comes to minimizing CPU, that's typically the best approach. But in some cases, you may also want to put in a limit, some type of limiter, and say it cannot go. Maybe the memory cannot go above this level. But yeah, usually the easiest thing is simply move any of that processing to a gateway node.
Awesome. Thanks everyone for all the great questions. Looks like that's it, Mike.
Great. I appreciate all the questions. And I know we'll follow up a little bit, and we'll send out some of the details that we mentioned as well. But thanks to everyone for joining. I know that we'll have some additional webinars in this series that are coming out, and they'll be announced shortly. But I appreciate it. Thanks. Have a great day.
Thanks all.